Welcome to the first video of Unit 11. We're going to start talking about the derivative and the alternative form of the derivative. First of all, we've done a lot of build-up to calculus and done some stuff that leads into the concepts of calculus. But this is your first official step into the world of calculus. So congratulations. What are different ways that point A and B can be labeled in the figure here? Well, let me get this to scroll down. So point A and point B here, there's a couple ways. Like you could say point A is x1 and y1. You could say it's x1 and then f of x1. You could also say it's just a, b, and you could just say x and f of x. And then for point B here, you could say that it would be x2, y2. You could say that it's x2 and then f of x2. You could say that it's c comma d. And you could say that it is x plus the change in x, because notice this would be, from here to here would be delta x. So it would be x plus the change in x, and then it would be f of x plus the change in x, or delta x. All right, so for the purpose of this here, we're going to use the last ones, the a, so we're going to call this x and f of x, and then b is going to be x plus delta x, and then it's f of x plus delta x. All right, so if you look at figure 2, as point B approaches point A, notice that the change in x plus x is going to get closer to just x, right? As it approaches here, right, the change in x is going to get closer to x. All right, there's two types of lines here. The first one, this A, the one that connects A and B, is what's called a secant line. And then this last one that just goes through A is what's called a tangent line. So as delta x, the change in x, approaches 0, meaning as the secant line becomes closer to becoming a tangent line, notice that the secant line approaches the tangent line, meaning as the change in x approaches 0, the slope of the secant line approaches the slope of the tangent line, meaning they become one and the same almost. So the derivative of f at x is the limit as delta x approaches 0, meaning the change in x, of, and remember, slope is always y2 minus y1, y2 minus y1. So here it would be f of delta x plus x minus f of x all over x plus delta x minus x. We'll notice these cancel, so it's just going to be f of delta x plus x minus f of x over delta x. And that is the derivative of a function, is basically the slope of the tangent line. So it's f of delta x plus x minus f of x all over delta x. The limit as that change in x approaches 0, provided the limit exists. So the definition of derivative is the slope of the tangent line to a curve at any point on the curve. So the slope is the derivative of the function. And what you're finding is an equation that represents the slope of the curve. And at the bottom, here are the different ways that you can write the derivative. You can say dy dx, which means the derivative of y with respect to x. You can say d dx of f of x, which is the derivative with respect to x of f of x, or d dx of f of x. And then you could say the derivative with respect of x, with respect to x of y, which is this d sub x of y. The most common one is this first one, dy dx. That's the most common one, besides just saying f prime of x, which is derivative. So when you think of derivative, you need to think of the word slope. Slope and derivative are the same. So if I were to say the word derivative, you need to say slope. When I say slope, you need to think and say derivative. All right, they should become one and the same. If you want to start chanting, feel free. Derivative, slope, slope, derivative. You can chant. All right, so finding the derivative of a function and the equation of the lines tangent to a function at specific points. So first, let's find the derivative. So f prime of x is equal to the limit as the change in x approaches 0 of f of x plus delta x minus f of x all over delta x. So first, it might be good to figure out, well, what is f of x plus delta x? Well, by substitution, that becomes x plus delta x to the third minus x plus delta x plus 1, and then minus f of x, so that's going to be minus x to the third minus x plus 1 all over delta x. So when you multiply this out, you get x to the third plus 3x squared delta x plus 3x delta x squared plus delta x to the third, and then distribute the negative, so you get minus x minus delta x plus 1 minus x to the third plus x minus 1 all over delta x. And if you notice, here some things cancel, like the x to the thirds, the x's, and the 1's cancel. So you're left with So you're left with 3x squared delta x plus 3x delta x squared plus delta x to the third minus delta x all over delta x. So if you notice, they all have a delta x in common. So I'll factor that out so that, notice they'll cancel. So you basically have 3x squared plus 3x delta x plus delta x squared minus 1. So when you substitute in the 0 to find the limit here, you get that it's 3x squared minus 1, and that is the derivative. So that is the equation for the slope of any point on this curve. So now the original question said find the equation of the lines tangent to the function at 0, 1, and 3. So first of all, when you put 0 into the original function, you get 1. So the coordinate is 0, 1. Now to find the slope at 0, well, that's 3 times 0 squared minus 1, which is negative 1. So the equation for the tangent line at 0 is y minus 1 equals negative 1 times x minus 0. So that's the equation line at 0, 1, or at 0. Now at 1, well, f of 1 is equal to 1 to the third minus 1 plus 1, so it's equal to 1. So that means the coordinate is 1, 1. And then the slope, so f prime of 1 is 2. So now you write your equation, y minus 1 equals 2 times x minus 1. So that's the equation at 1. And then the last one at negative 3. So when I put negative 3 into the original function, I get negative 23. So that means my coordinate is negative 3, negative 23. And the slope, f prime of negative 3, is 3 times negative 3, or f prime negative 3, 3 times negative 3 squared minus 1 equals positive 26. So when you write your equation, you get y plus 23 equals 26 times x plus 23. And that is your equation for that one. All right, so horizontal tangent line. So if you had a curve, kind of like a wave here, notice you would have some horizontal tangent lines at the top or the bottom of each curve. Those would be horizontal tangent lines. So if you notice, those all would be horizontal tangent lines. So what is their slope? Their slope is 0, because any horizontal line has a slope of 0. Where do they occur? They occur at peaks or troughs, like bottom or tops. Basically the changing points from going from increasing to decreasing. Possible locations, you could call them local or relative, depending upon the situation, maximum or minimum values. And what will the value of the derivative have at these points? Well, if the slope is 0, that means f prime of x is 0. Vertical tangent lines, well, some places that vertical tangent lines would occur, like if you had a function that looks something like this here, where notice the vertical tangent line would go there. Or if you had something like the square root function, where it went like that, and then you could have a vertical tangent line here. All right, either way, vertical tangent line, the slope is undefined. Where do they occur on the graph? They occur at points that are vertical. And what will the value of the derivative be? It will be that it does not exist. So there would be no value of the derivative at these points. Because the definition of the derivative is truly a limit, this means that in order for there to be a derivative, that the derivative from the left of any function has to equal the derivative from the right of any function. So that implies that there are no sharp turns. Some things that have sharp turns would be like absolute value. So that's not allowed. It needs to have nice smooth curves like polynomials. And it has to have no vertical tangent lines in order to take the derivative at that point. So far, we've talked about to find the derivative of a function, meaning the equation of the slope of a line. But let's say we're trying to find the derivative of a function at a certain point, all right, meaning the slope. So to find that at a certain point, all right, let's say this is c and f of c, and then this is x and f of x. So the derivative is just f of x minus f of c over x minus c. All right, because if we're going from this point, then the change in x is just going to be whatever this x value is. So we're finding at a certain point, there is no, we just take the value, the function, minus the value of the function at that point over x minus c. And that gives us the derivative at a certain point. That's easier to use if you have that point that you're trying to find. So for example, the alternative form of the derivative to find the equation of a tangent line at x equals -2. So if I just knew one specific point, instead of finding the derivative of the whole function, I could say f prime of -2 is equal to the limit as x approaches -2 of f of x, which is x to the third minus x plus 1, minus f of -2. Well, if I put -2 in, so I get -2 to the third minus -2 plus 1. So you get -5 all over x minus a -2. So that means I have the limit as x approaches -2 of x to the third minus x plus 6, because this is plus, over x plus 2. Now you might be thinking, well, how do I factor this? But remember, in order to find the limit, we're going to have to cancel the x plus 2, so that means I could do synthetic division. 1, 0, -1, 6. Bring down the 1, multiply, add down, multiply, add down, multiply. So that means I'm left with, after I factor this, it's going to be x plus 2 times x squared minus 2x plus 3 over x plus 2. So notice the x plus 2's cancel, and that means it's the limit as x approaches -2 of x squared minus 2x plus 3. So when you put the -2 in, you get 11. So that means that's the slope. So when we put -2 in, we got 5. So that means the point is -2, 5. The slope is 11. So when I write my, or sorry, -2, -5. When I write my equation, it's y plus 5 equals 11 times x plus 2. That's the equation of the tangent line at that point. So that works when I'm only dealing with one point. So as it noted in the bottom, alternative form was is used when you have one value, whereas the definition of derivative is when you're coming up with an equation for the slope of the function. All right, go ahead and try the next two examples, and then I'll show you the answers. All right, so looking at number 1, remember first you have to find the value of the function at 14. and then use the alternative form of the derivative to find the slope at 14, which becomes 31, and then you can write the equation using the point 14 and 236 to write the equation of the tangent line at that point. Same thing for number 2. You're going to substitute in 14 and get 9, and then you're going to find the slope of the function at 14. So you find the slope to be 1/5 when you do the work, because you have to rationalize the denominator. Let's see if I can get a shot in there. Yeah, there you go. So you got to rationalize the denominator, rationalize the numerator, and then you can write the equation of the line using the point 14,9. So this is the equation of the line that would be tangent to the function at the specific point. All right, so the next question says algebraically find the relative maximum minimum of this function. The sketch has been provided to help you visualize this, and a graph will not always be provided, but remember the maximum and minimum values right there and right there. Remember, the slope of the tangent lines are always 0. So what you want to do is find the derivative of the function. So remember, that's the limit as the change in x approaches 0 of, in this case, it's going to be x plus delta x to the third minus 6 times x plus delta x squared minus 7 times x plus delta x plus 10 minus, I'm going into the thing, x to the third plus, x minus x to the third minus 6x squared minus 7x plus 10 all over delta x. So let's simplify this. So we have to cube this. So remember, that's going to be x to the third plus 3x squared delta x plus 3x delta x squared. Then you have to square this, so minus 6 times x squared plus 2x delta x plus delta x squared minus, and then you distribute the 7, so it's 7x minus 7 delta x plus 10, and then we have to distribute the negative here, so minus x to the third plus 6x squared plus 7x minus 10, and that's all over, all of it's over delta x. So the last thing is to distribute the 6 here, and then we can start canceling stuff. So we have x to the third plus 3x squared delta x plus 3x delta x squared minus 6x squared minus 12x delta x minus 6x squared minus 7x minus 7 delta x plus 10 minus x to the third plus 6x squared plus 7x minus 10. So if you notice, and that's all over delta x. So if you notice, the 10s cancel, the x to the thirds cancel right there, the 7x's cancel and the 6x squareds cancel. So when you take inventory here, you have 3x squared delta x plus 3x delta x squared sorry, I canceled out the wrong thing here because this should be a 6 when I multiply 6 delta x squared. So this should cancel. So it's going to be minus 6 delta x squared and then minus 7 delta x all over delta x. So when you take the limit as delta x approaches 0 and you factor out the delta x, you're left with 3x squared plus 3x delta x minus 6 delta x minus 7. So when you put the 0 in for the delta x, you're left with 3x squared. Sorry, I forgot the 12x delta x here. So when you factor out the delta x, you're actually left with minus 12x. So then when that equal, you get 3x squared minus 12x minus 7. So that is your derivative. So now, to figure out where it has a relative minimum or maximum, you need to know where the slope is 0. So you want f prime of x to equal 0, which means 3x squared minus 12x minus 7 equals 0. So you're going to have to do the quadratic formula. And when you simplify all that, you get 12 plus or minus 2 rad 57 over 6, which is equal to 6 plus or minus rad 57 over 3. So that means that when you put those values in, so when you put in 6 plus rad 57 over 3 and 6 minus rad 57 over 3, those will give you either the maximum or minimum. So you have to put these values back into the function, and you'll find out that f has a relative minimum of negative 51.877 at x equals 6 plus rad 57 over 3. And when you put in 6 minus rad 57 over 3, it has a relative maximum of 11.877 at 6 minus rad 57 over 3. And if you check the graph, you'll notice that that makes sense, that the smaller x value should have the higher y value and vice versa. So if you check the graph, that makes sense. All right, so we'll stop there for this video, and next one we'll talk about how differentiability and continuity go together. All right, so I hope you enjoyed your first experience with derivatives, and talk to you next time.